Alright, today we are going to do our first geometric proofs. Right? Everything we're going to do in this section here deals with proving things about line segments. Right? Whenever we look at a proof, we will always have some given information, and then we will be told what we want to prove. So in everything we do, this will be the first line, this will be the last line of our proof. Okay? So just like when we did our own proof, is always just whatever we're given. So here, the only information we're given is that E is the midpoint of DF. So my reason is given. So now, what we want to look at in proofs is how we get from one step to the next. Right? So if I know that E is the midpoint of DF, okay, so in this diagram, we know E is the midpoint of DF. Thinking about our reasons, okay, our definitions, our postulates from yesterday, can I say that DE is equal to EF? Right? If I know E is the midpoint, definition of midpoint, right? If I know E is the midpoint, our definition of midpoint tells us that it splits the segment into two equal pieces. So we can just say definition of midpoint is our reason. So now, again, we want to look at, well, how did I get from this step to this step? What changed from this equation to this equation? What can you guys see that changed from step 2 to step 3?
DE was added to both sides?
Yeah, I would say DE was added to both sides of the equation. So if I'm adding the same thing to both sides of an equation, what property is that? Addition property. Yeah. Right. So even though these are geometric proofs, I mean, we're still looking at some equations, right? So we could still add the same thing, subtract the same thing, divide, multiply. Those things will still crop up here. Right? Well, now, again, we're looking at what changed from line 3 to line 4. Okay, so what's the difference between these two equations? We have DE plus DE equals DE plus EF, and now we have 2DE equals DE plus EF. Right? Exactly, yeah, we just combined these and said that was 2DE. So we can just say that's combined like terms. Right? The DE and the DE are like terms, so we're just combining them together. So now, they claim DE plus EF equals DF. How can we claim that? What is it? Subtraction? I don't know if we can claim that that's subtraction. This one is slightly different, okay, in that we're not necessarily looking from this line to this line. We also may sometimes need to use the picture. Okay? So what they're claiming is DE plus EF equals DF. Right? How can I claim that this piece plus this piece equals the whole thing? What's that? Not division. Yeah, this one is the segment addition postulate. Right? That was the one where we said if we add two pieces of the segment together, we can get the whole thing. And that's exactly what's happening here. Right? DE plus EF equals DF. So now, to get to this final line, somehow now they claim that 2DE is equal to DF, which is what we want to prove. But using what we've already said, how on earth do we get to this line? Okay, this one, again, it might be a little more difficult to see it first, okay, because we have to think about two of the previous lines. Okay? So in lines 4 and 5, we said that DE plus EF is equal to 2DE, and then that same thing, DE plus EF is equal to DF. So I've got DE plus EF equal to two different things, right? Well, if they're both equal to DE plus EF, they would be equal to each other, right? So since DF is equal to this and 2DE is equal to this, they're equal to each other. What property lets me say if two things are equal to the same thing, they're equal to each other? Transitive property. Okay. So on these proofs, okay, for the first set of proofs that we're going to look at here, we're given all of the statements. Okay, we just have to fill in the reasons. Right? So it's partly what we did yesterday, right? Looking at a statement and trying to just recognize, well, what's actually happening. Okay, but a little bit of it is also saying, well, if I look at the last line, how did I get to this next line? Bless you. Any questions so far? All right, let's do another one together here. Let's do number 2 together. Now, from what we were given in number 1, we weren't really able to mark anything on a diagram, but when we're given that segments are congruent, it's a good idea to start by marking that on the diagram so that we can see what's happening. So the first piece of information I'm given is that KL and LN are congruent. Okay, so saying KL and LN are congruent. Right? Those two things are the same. So mark that on the diagram. We talked about this a little bit. We can use the same number of tick marks. Right? So if I put one tick mark on KL and one tick mark on LN, that tells me, just looking at the diagram, that they have the same length. The other piece of information that I'm given is that LM and LN are congruent. So again, I can mark that on the diagram. Okay? Since I already have one tick mark on LN, I can also put one tick mark on LM to show that they're congruent. All right, so now we can try to fill in our missing pieces of information here. So the first line is, what's the reason for the first line? Given. Right? That's just what we're told. Now, how do I go from line 1 to line 2? Right, so in line 1, we're saying the segments are congruent, and then in line 2, I'm saying the lengths of those segments are equal. Which of my definitions or properties or postulates lets me say if segments are congruent, then their lengths are equal? Definition of congruence. Okay, the definition of congruence lets me say if segments are congruent, then their lengths are equal. Well, now they just claim that KL is equal to LM. How can I do that? So looking at the information in line 2, how can we claim that KL is equal to LM? Not yet. So we want to prove that L is the midpoint. So we can't use midpoint yet. Sebastian?
Definition of midpoint?
So our final line is going to be definition of midpoint. Once I prove that KL and LM are equal, then I can say that L is the midpoint. But how do I first prove that those two things are equal? Well, you're on the right track. But since these are two separate equations, I can't just subtract it. So if we look at line 2, here, I've got two things both equal to Ln, right? I've got KL equal to Ln, and then I also have Lm equal to Ln. We could use substitution here. That would work, okay? So if we look at this equation to this equation, Ln just became Lm. I'm allowed to do that because I know that those two things are equal. So we could say we substituted Lm in place of Ln. So substitution property would work here. There is actually another one that would work here. Right, so substitution property definitely works. Another one that would work, okay, is one that we used in the last one. Okay, I'm saying that two things are equal to the same thing. So both KL and LM are equal to Ln. If they're both equal to the same thing, then they would have to be equal to each other. Which property lets me say that? Transitive. Yeah, if two things are equal to the same thing, they're equal to each other. So we could use substitution here or transitive. Both of those would be correct. Okay, and you don't have to write both of them. You can just write one or the other. Right? Lm. Now I can claim that L is the midpoint of Km. I think some of you already said this. Right? So if I know that these two segments are the same, then we can say L is the midpoint by definition of midpoint. Yeah. So these proofs are a little different than your traditional math class, right? It's not just solving an equation and getting one right answer at the end. This is more logical thinking. Okay? Questions so far? All right, you guys think you can try one, or you want to do another one together? Another one together? All right. Let's do another one together. So the number 3, there's a little bit more going on, right? There's 7 reasons that we have to fill in here. Okay, so again, let's just take a look at what we're given first. I don't remember seeing a red notebook left in here. Is that your math notebook? Oh, then it doesn't matter.
Oh, yeah, of course.
Sorry, Jackson. All right, so on this one, we are given that PQ and TQ are congruent. So I'm going to mark that on the diagram. Okay, PQ and TQ are congruent. Then separately, I'm told that UQ and QS are congruent. So since these are a whole different statement, I'm going to put a different number of tick marks over here. Okay, so this, what I've drawn in the diagram tells me these two are congruent, and separately, these two are congruent. Okay? My goal then is to prove that PS, this whole length, is congruent to TU, this whole length over here. So they give us the statements, we just need to fill in the reasons. What's my reason for the first one? Get it. So now they say if the segments are congruent, those same lengths are equal. What's my reason for that? Definition of congruence. So now they claim that PQ plus QS equals PS, and also TQ plus QU equals TU. How can I claim that? Segment addition postulate, right? Looking at the diagram, right, we're just saying this piece plus this piece equals the whole thing, and this piece plus this piece equals the whole thing. So that would be our segment addition postulate. So now they claim that TQ plus QS equals PS. How can we claim TQ plus QS equals PS? Yeah, if we look at here to here, right, these two equations are almost the same. The only difference is they replaced PQ with TQ. We're allowed to do that because we know they're equal to each other. So we just substituted TQ in place of PQ. Now, they say TQ plus QS equals TU. How can I claim that? All right. How can I claim that TQ plus QS equals TU? Yeah, we're actually just looking at this equation now. Okay, and the only thing that changed from this equation to this equation is that QU got replaced with QS. So it's substitution again. Because up here we said those two things are equal, so I can replace one with the other. So substitution. So now somehow they claim that the length of PS and the length of TU are equal. Yeah. All right, so if we look at both lines 4 and 5, we've got the same thing on the left side of the equation, right? TQ plus QS. So we're saying that PS and TU are both equal to that same thing. Therefore, they would have to be equal to each other. That would be transitive. Then finally, if the length of PS equals the length of TU, how can I claim that segment PS is congruent to segment TU? Yeah, that's the definition of congruence, right? If lengths are equal, those segments are congruent. Depth of congruence.
All of these are from property.
15 minutes. We're going to do a lot of these.
Wait, do we have to memorize all of these?
Yeah. You have to know what they are. I mean, you'll have like a bank of possible options, but you have to know what they are.
You know, Mr. Fach actually did not write the
You
geometry
know,
curriculum.
one of my favorite teachers,
And
and
if
you do
you-
something like this, and you just drop down, and I'm like,
You'll find out as we go along that I'm just a jerk.
what makes it stand for better.
All right. Any questions so far? Okay. You guys feel like we can try one?
Yes.
All right. So let's try number 4 here. Now I do want to give you one hint as you're working on this. Okay, we said the first line is always given. Okay, and that's true. Okay, the first line is given information here. But we are actually given another piece of information. Okay, they split up the givens in this one. So they use K as the midpoint and M as the midpoint first. And then we're also given that the length of JK is equal to the length of MN shows up here in line 3. So we're given that piece of information as well. Okay? So let's take a few minutes here to try to work through number 4. See if we can fill in these reasons. Yeah, on a lot of these, it actually is. Yeah, on 3, 4, 5, and 6, it is. That's just kind of a coincidence here. They all end up All right, let's take a look at number 4 together. As I was walking around, it seemed like most of you were starting to get these down. Okay, still a couple mistakes here and there, but this is brand new, right? So I definitely don't expect you to get it the first day. Right? We're going to do plenty of practice on this proof stuff. All right. So as long as we just get a little bit better every day. So I guess I don't know why I erased those. We said that the first and the third lines were given, right? Well, the second line. Okay. So we're given that K is the midpoint of JL. Then they conclude that JK equals KL. Right? So if I know K is the midpoint of this, they said, well, that means that this has to equal this. That's our definition of a midpoint. Okay? The definition of a midpoint just says a midpoint cuts a segment into 2 equal pieces. Right? Then we were given line 3 as well, JK and MN. So we're given JK is equal to MN. Then somehow they conclude that MN and KL are the same. Okay, so this second piece, they already, this is just the same thing as right here. Right? They didn't change LM and MN being equal to each other. What they did change was this first statement. Okay? So look at this. Okay? They said, well, up here, we know that KL and JK are equal to each other. And then I know that MN and JK are equal to each other. So they said, well, if KL and MN are equal to the same thing, they would have to be equal to each other. So one way of stating this would be transitive property. Another way would be substitution. Okay? They said, well, if JK and MN are equal to each other, I can just replace JK with MN in this statement right here. Say MN equals KL. So both transitive and substitution would work for line 4. Now, for line 5, okay, now they claim that LM and KL are equal. Okay, this is actually really similar to the logic we just used. Okay, we could either say MN is replaced by LM in this equation because I know those two things are equal. So we could say substitution. Or we could say KL and LM are both equal to MN. Therefore, they're equal to each other. So again, either substitution or transitive would work here. Okay, I'll jot down substitution. The next one, okay, they claim that KL is equal to LN. Well, all we did was take this statement and flip it across the equal sign. Right? Flipping across an equal sign is just the symmetric property. And then finally, if two lengths are equal, they claim the segments are congruent. That's definition of congruence. Okay? Questions?